Hi, I'm Dr. Jill Perry, and I'm an Associate Professor of Mathematics Education at Rowan University. Welcome to Keying English Learners into Mathematical Content, the Things I Notice approach. I encourage you to pause the video right now and gather some of the things that I've indicated in the large blue rectangle, including finding a colleague with whom to maybe do the math, or a friend or family member. It'll be more interesting and you'll probably learn more if you do that. And if you can't, that's okay. It'll still be interesting and you'll still learn lots. Another thing you might want to do is locate our slides and open a browser and have that handy. We'll have a lot of the things that I want you to work on and all of the slides for this presentation as well. So I'll pause for 5 seconds, but you can pause for lots longer. Fantastic. Welcome back. And I would like to begin with just talking about an overview of what we're going to do, so just the flow for the day. So we'll take a quick overview of the approach. You'll engage in the things I noticed as best we possibly can. We'll talk about the routine in both face-to-face and virtual environments, what it looks like in those spaces. We'll look at a few types of things I noticed that you can use for different instructional purposes. We'll discuss how to create, plan for, and enact them. And then I'll end with just a few closing thoughts and some recommended resources. There are two really rich places to start in terms of supporting students, especially English learners, in a math classroom. So why we're here, big picture, I want to share a routine with you that works with English learners, works to support them. It is wonderful for all students, but we'll pay attention to how it supports English learners. And by the end, I want you to have a sense of why you would do them, how you would do them, and what you can use them for. The things I notice approach assumes a few things. And the first is that all students are together engaging in a community of mathematical discourse. So regardless of first language, regardless of varying abilities, students are together engaging in a community of mathematical discourse with support of teacher or teachers, of course. And the second is that we as teachers can support children as they move through the oral language register from everyday to technical modes. And remembering that all of our students are engaged in doing this. English learners are engaged in doing this in two languages. So they're really working differently and harder in some ways. They have to work harder to access the math. And our goal is to help students access the math. So I want to start with the instructional purposes of things I notice. There are really 4 ways in which I use things I notice. The first is a way to build and activate background knowledge, understandings, and skills. Another is as a quick assessment prior to teaching a new unit. A third is just to launch a rich or a complex task. And the fourth way is to focus students on specific mathematical representations. If there are things I really want them to pay attention to, then I will use the things I notice approach to do that. And again, we'll talk about how that looks in for each of these purposes. So the first instructional purpose is as a means to build and activate background knowledge, understandings, and skills. So this is a great way for us to get started together, because it will help you make sense, I hope, of the entire routine. So when I introduce a routine, so I'm introducing a new routine, I would typically have a student read the slides. That's why you'll see that it's written in this way. So it's going to probably sound strange to hear me say Jill is going to give us a task, but it's because children would be reading this. So we are going to do a things I noticed together. Jill is going to give us a task. We are going to think about it on our own and write down what we noticed for 1 minute. When Jill is ready, she's going to ask us to talk with our partner and take turns sharing our thinking. Then we will come together as a group to share our thinking. And you'll notice that I have paired language off to the side. What I would do is either have a student read this aloud, especially in a class where there are not lots of different languages. In a class where there are lots of different languages, I approach this a little bit differently. but I want every student to have access to the instructions in their language. And I also would like students to have access to a fluent reader reading them those directions, those instructions in their language. And so in this case, having students read or having me read the instructions in English, that's pretty easy for me. Having it in another language is rather challenging. So sometimes we can lean on friends who speak language that our students speak. In other cases, we have to draw from other resources. So sometimes it's easy to access either through a community center or churches. Sometimes it's easy to ask someone to translate something from English, or find someone who will translate something from English into a language that our students speak. And another place to go is a college or university. There are often world language programs in most universities, and professors are actually pretty willing usually to translate something if they know that it's to help children. So if I have very specific instructions, I will reach out to colleagues who speak those languages to translate into those languages. And oftentimes I will ask them to read, and they are often very willing. Sometimes they'll even have their college students do it. It's good practice for them to engage in an oral reading of something that can be kind of technical. So I encourage you to reach out to community and university resources to bring a student's language into your class. It doesn't mean you have to understand the language. You do have to trust that this language is that the instructions are going to be translated well and read clearly. But again, you have community resources, and I really encourage you to use them. I could not do this on my own. I can't do paired languages or bring students' languages into my class on my own. So we're going to engage, so that was a big teacher timeout, but we're going to engage in things I noticed. If we were in a class together, you would have a sheet of paper. At the top, it would say, these are some of the things I noticed, and there would be this image that you see here. But, and again, I might have the instructions in a student's native language. But we're not together in a class. So we're going to do something that the way that I engage with students online in virtual environments is to have slides ready for them. So if you will click on, not yet, but and when I'm finished, if you'll go to slide 2 in our Google slide, and then take 2 minutes. I know it said 1 minute, but I want you to take 2 minutes because this is a pretty rich one. So I want you to, on your own, for 2 minutes, just write down the things you notice about the image that you see. So what do you see here? So I'm not going to pause for 2 minutes. I'm going to pause for about 5 seconds, but I encourage you to pause. Take 2 minutes just to let your math brain wander. Okay, welcome back. I hope you had a chance to notice some amazing things. I'm sure you did. If you have a partner handy, so sorry, again, here are the paired language. Here's the paired language. So if you, what I'd like you to do now is actually go back for 2 minutes, and we're going to toss a word bank in there. You might have used some of these words, but you might not have used some of these words the first time. So I would like you to go back in and continue to notice some things, but this time I want you to try to use some words from the word bank to add to your findings. So the words are even, odd, column, row, factor, and multiple. And I'm going to switch to the slide with the paired language, but again, you pause for 2 minutes. All right, welcome back. I hope you were able to add to your noticings using some of the language some of the words from our word bank. So now what would happen is that you would actually, in a class, you would actually just turn and talk with your shoulder partner or your knee partner, depending on how your class is set up. But this is what I would ask children to do. For 3 minutes, I'd like them to take turns sharing the things they notice. And I really do work on having them understand what take turns sharing means. So I might grab another teacher, a math coach, an administrator, the media specialist, somebody to come in. It doesn't have to be another math teacher. It can be any teacher in the building, but to come in and model with me what it means to take turns sharing our noticings. So I'll have a colleague come in, and for the first time that I do this, they do the things I notice while the children are working, and so do I. And then what we do is we come together and we model taking turns sharing. And so when my partner says something that I don't have, I write that down and I put their initials next to it. And they do the same for me. And when we then look to try to find something new together, then I put a star next to what we found together. So children are actually just continuing to work on the same sheet of paper when they're face to face. But again, we can't do that here. So on slide 3, you'll find out what I do when I send children to breakout rooms to work with their partner or partners. So what I have them do here is the same thing. And I don't want to spend a lot of time here, but the directions here for slide 3. But these are the things that I have asked children to do. And they work on slides that look like this. And so these slides are also in the slideshow. So if I know there would be 2 children working together, I have them work. I put an image in the lower right-hand corner usually, and I support them with one thing I notice. So one student writes one thing, and I tell them that when I can watch them, if they're doing this in Google Slides, I can actually watch all of the pairs work. So I can see how the children are working together. I can also do this in Jamboard. I can have one of these slides across a Jamboard and have children go to the slide number, put their names on it, and then jot down the things that they each noticed. So sometimes they copy paste, sometimes they type new, sometimes they write, depending on the environment that we're in. Those of you using Seesaw, you have lots of supports in place for students to do this and to collaborate. So then I have them jot down something they noticed together. And if you have a partner with you now, I would like you to try it out. Just see what happens if you take turns sharing. And then if you thought of that, you can put a check mark next to it. You can just copy the little check mark. If you didn't understand it, put a question mark next to it. If you understand it now, put a thumbs up next to it. Something I didn't think of that, but I get it now. Put a thumbs up next to it. So, and all of those instructions are in the other slides. So this might be a good place to pause if you have a colleague working with you and to take turns sharing. And if you have 2 colleagues working with you, here's what that would look like. And if you have 4 people working, then break up into pairs. So I'm going to pause while you pause. And welcome back, or glad you're still here. So then we share as a class, right? So, I mean, think write pair share, think pair share with this idea of noticing. What I have students come together, the first question I usually ask is, what's something you noticed that you think a lot of your classmates noticed? And what that does is orient students to each other's thinking. So I want them to think, gosh, what's something that a lot of other kids probably noticed? I really want them to think about audience, because if we're trying to build a community of discourse, one of the things we need to consider is the people to whom we're speaking and what are their points of view. And so we're orienting them to each other's thinking, others' points of view. And then I move to what are some of the other things you noticed. The phrases that are on the sentences, sorry, that are on the screen now, these 4 sentences that you see, but these 2 big questions, those are in my teacher head usually. So sometimes I'll put it on a slide, but most times I just say it to kids. I just say it to students. And that way we don't get tied into only them thinking they have to notice something that somebody else noticed, but it's a really good place to get us started, is what something you noticed you think a lot of your classmates noticed. And then I take a vote, by the way. I say, gosh, how many of you did notice that? Who else noticed that? Give a thumbs up, or in class, we say, yes, I agree, or me too, like, right? So this is me too. Kids will give a thumbs up. They'll say, yeah, I did too. I thought of that. So this idea that they're listening to each other and actually listening for what others say. And I want to take you through kind of my annotations from a conversation with students around what you're seeing here. I'm going to put up, these are the ways that we engage in a class. My colleague Rob Wyman and I are very focused on what students should be doing. So expectations for what they should be doing, not for what they shouldn't be doing. And I invite you to take a look at those. The slides are also in the, you could pause here and read them. But since we're not sharing, I'm not going to take time to go over all of that. But I just, one, you can pause, two, it's in our slideshow. So this is what happened in with a group of fifth graders. So these are some of the things I noticed. So somebody said the first row counts like counting. And then they said 2, 3, 4, 5, 6. And then we talked about column and row. So somebody else, I said, did anybody else notice that? And somebody else said, I thought it was a column. And so we hashed out column and row right there. I put a line through row and put column above it so that they know there was a correction. I didn't erase it because I want them to see this is something we confuse a lot, and that there was a correction we made. We do that, we revise our thinking, and I like to keep it present. Then somebody else said the rows go up by the same number, and it skip counts. Then I said, what do you mean by the rows go up by the same number? And they said it skip counts, 2, 4, 6, 8, 10. And then somebody else said it by twos. So skip counts by twos. And so I tried to annotate with this next one. It says it skips 3, 5, 7, and 9. So when they were talking about skip counting, I think you can probably hear it. When they were talking about skip counting, they were saying which numbers you skipped, and the others was saying that they skipped by twos. These are all ways of saying the same thing. And this is what builds communities of discourse. It's also what helps students engage in expert thinking around math, is that they can say something in a lot of different ways. The more different ways I can say something, the bigger my understanding of that concept is. So then somebody else said, so I said, did anybody think of it a different one? They said, yeah, they add 2 each time. Like 2 plus 2 is 4 and 4 plus 2 is 6. So you see the green annotations here. So I did the +2, but I wrote out what they said. And then somebody said the next number would be 12. Like you skip 11 or 12. So now they're noticing things. They're just coming up with other things, right? So they're making their own math at this point. Awesome. And so we talked about that, and we asked who agrees, who disagrees. Nobody disagreed. They thought it was pretty sound logic. And the next person said, I said, so what's something else you noticed? And somebody said the next row is by 3s, and then 4s, and then 5s, and then 6s, right? So then I tried to annotate what they said. And then somebody else said that you add 3, add 4, add 6. Like that's what you're doing each time. So when it goes up by 3, 4s, 5s, and 6s, I said, what do you think the student means by that? And somebody else said, they mean that you add 3, add 4, add 5, add 6. And somebody did note that you couldn't write in, it would be really hard on the bottom row to write in all the numbers that were between, right? You'd have to write in 7, 8, 9, 10, 11. So children are thinking about the order of numbers. They're thinking about all kinds of things. And they're looking at something that makes sense to them. And they're saying many of the same things in many different ways. And that's really important. So then this is another avenue that we went on. So at the end of it, I want to talk about the word bank. So at the end of when I gave children the word bank, many of them did not use factor or multiple. They actually asked, do we have to, I don't know what is that? Like what are those words? Do we have to use them? Do we have to use all the words? Some of them took a guess, said like multiples, like multiply. They didn't really have an idea of what was happening. And so we talked about, so somebody who did use the word multiple, what's a way that you use multiple? And somebody said the first row is multiples of 2. And so we talked about what multiples are. And I said, what did you notice that makes you say that? And that's a really key question, because this student made a conjecture, right? They named something and they said the multiples, the first row is multiples of 2. Well, anybody could say that. I could say, and it might be incorrect or correct. And if it's correct, as a teacher, I'm like, hey, they understand. But they don't really necessarily understand. So I went to dig a little deeper. I said, what do you notice that makes you say that? And the student said, well, 1 times 2 is 2, and 2 times 2 is 4, and 3 times 2 times 3 is 6, and 2 times 4 is 8, and 2 times 5 is 10. And so they said, oh, agree, kids agreeing. And then somebody else pointed out the next row, it's the same thing. 1 times 3, 2 times 3, 3 times 4, 3 times 5. Another student, the one in blue, thought, let's keep the pattern going and make it 4 times 5 and 5 times 3. So the children are starting to look for patterns, starting to think about how to organize it so it's easy to see the pattern. And then the columns are multiples too, somebody noticed. Right? So we talked about all the rows and how we'd write them out. And we use, think about how many times children are using multiples. So the columns are multiples too. And they talked about, so they did the one with 6. So the one in the middle. So 3 times 2 is 6, right? So they're talking about, they're doing lots of facts. They are using language lots of times, multiples over and over and over again. And then I got to ask, so then this other idea, this idea of the numbers in the second column are multiples of 2. They started to want to organize their thinking and prove these things. So they're engaging in reasoning and proof. I gave them an interesting thing to think about. I did ask them to use particular words, so I oriented them to that thinking. But so English speakers and English learners are both having lots of opportunity to use the language. And if children who speak a different, for English learners, if they speak in their native language first, in their first language first, then we do start to see them drifting into using English, because we've got paired words and they're hearing it a lot and using it a lot in a meaningful context. And so you have to know that, of course, I asked them about factors, who used factors, and they said, okay, so I used factors and multiples wrong. They had confused them. But then we started saying, so 2 is a factor of all the numbers in the first row. 2 is a factor of all the numbers in the third row. Like they started looking for all the numbers where there were factors, where these numbers were factors. And so just from this little bit of building and activating background knowledge, I can have children really explore and use the language so that they become more comfortable with using this technical language in math. These children confuse factor and multiple a bit less than children have or they had prior to engaging in this. And so it's a really great place. You'll notice I paired even, odd, column, row, factor, multiple. Sometimes we separate those, but for those of you who teach fact families, we know that keeping all of those things together can really help children make meaning, right? So we don't say that 2 plus 3 is 5, and 3 plus 2 is 5, and 5 minus 3 is 2, and 5 minus 2 is 3. We don't say that those are all different things. We just look at them all together as a family. These things that seem like opposites, the way we talk about opposites, are actually, it's very important for children to make sense of them together and use them so that they're getting practice using them in those contexts. So just a big picture of how things I notice can, by giving children something interesting. And by the way, this is just a segment out of a multiplication table. Some of you noticed that, I bet. I bet some of you also noticed that this is like a set of ratio tables, like 2 over 3 equals 4 over 6 equals 6 over 9. If you take any 2 rows, it generates equivalent fractions. It's really pretty amazing. Just because we take a chunk out of a representation children see a lot, a multiplication table. So if you need to stop and make sense of things and write things down, then do. If you want to dash an email off to me right now at perry@rowan.edu, do. Say, we're in the middle of this video. You said this stuff. We have questions. Ask them. So I wish we could just communicate right now, but we can't. So I want to move into the other instructional purposes. And so the first one is that the first one is building and activating background knowledge. Things I notice as a tool for assessing prior knowledge before I teach a unit has been pretty amazing. And I'll give you an example as to why. So I do encourage you to go to slide 6, take a few minutes to jot down the things you notice about what you see here, and then come back after you've paused. I'll pause for a few. Okay, moving on. Welcome back. So these are some of the things students noticed. I'm just going to put them out here. They noticed it's a circle, that there are 4 colors. It looks like a spinner. Green and yellow are equal. So you probably have some of these. The green is 1/4, yellow is 1/4, blue is 1/4 but smaller, and red is 1/4 but bigger. So I'll give you the context here. This is a group of 9th graders. And we were going to be working on a probability unit. So students recognizing that this looks like a spinner is pretty great. Students thinking that blue is 1/4 but smaller and red is 1/4 but bigger is problematic. And I said, so do you mean that blue is smaller than 1/4? And they said, no, it's a 1/4, but it's just a little bigger. And it's 1/4 but a little bit smaller, right? So that gave me lots of information that I needed prior to this unit on probability to be able to move on, because we had to really go back and discuss what it means, what fractions really mean and what they are. And so I knew before I started talking about probability, some of the things that I wanted to visit, but they understood the relationships of the pieces. They could identify 1/4 as one of 4 pieces, but what they were missing is that it's one of 4 equal pieces. And we had to go back to that together. As a side note, they actually could say, if this were a spinner, you would probably land on red the most and blue the least. Like, they could say that. They could actually say those things. So math is just so complex. They just couldn't reach around this idea of not all being 4ths. So as a pre-assessment, things I notice is a really great way to engage students. And I bet you're already thinking, if you are already thinking about it, what are some things, so what are some representations that will show up in your next unit that you want to know what your students already have understanding about? And just give this to them. And what I do when I'm doing something as a pre-assessment, when I'm using the things I notice as a pre-assessment, what I do is ask children, or I just tell children, we're not going to do all of the things I noticed together. What we're going to do together is just, you're going to work independently, and I'm going to collect it, and I'm going to use it to help me know where to go next. So to help me know how to best teach you. So you might want to stop and take a pause just to write down some ideas, or really think, gosh, are there some representations that I could look at right now and have my children look at Monday to help me know about how to plan my next unit? Don't know if you paused or not, but welcome back. So another way that we can use things I notice, that I use things I notice, is to launch a rich or a complex task. So here's an example. Again, this is on slide 8. Take a minute or so out just to jot down the things you notice. Take as much time as you want, I guess, because you get to control the time. I'll pause for 5 while you go think and pause the video. All right, welcome back. I hope you thought lots of great math stuff. I hope you noticed some pretty amazing things. So these are just some examples of things that children have noticed. So a group of 5th graders, they noticed that over half the students do homework after dinner. And I said, how do you know that? Of course. What did you notice that told you it's over half? And somebody said, well, after they got 20 votes and before they got 12 votes. And so half would be 16. So, that's over half, and that's less than half. Some couldn't tell what half was. They just knew that there were more on the left and less on the right. So more after dinner, fewer before dinner. They're not the same. So dinner is more than half. Like, that's a pretty complex thing that they're thinking about. Then somebody said 8 more kids picked after dinner. And then somebody else, I said, so how do you know that? And they said, well, each of those things is 5, right? Each of those marks is 1, it's 5. We talked about how to count, and they talked about how they subtracted, and different children subtracted in different ways. Some just looked at the hash marks and decided how many were left. Other children converted them into our Arabic numeral system and wrote out what the numbers are. So they subtracted using our regular numbers, they said. And then somebody said 20 out of 32 picked after dinner. So they started moving into fractions more formally. Not all of the children were able to do that. And so it did help us surface some things we want to have surfaced before we started talking about the problem. And what I want you to think about is how engaging in the things I noticed task took the focus off getting the right answer. There is no right answer. Children are kind of creating their own math. It actually cues students into making sense of text and data and how they're related, right? They were looking at the text, they look at the data. If they're referring to the context, some of them used the children's names. They wrote Liam and Noah. Others didn't. So it helps students just get rid of their having to be an answer and just take time to do what good mathematicians and scientists do, which is get a sense of the surroundings before they start thinking about what they're supposed to find out about it. And then after children shared and discussed their noticings, they might do a couple things. They might just work to represent Liam's and Noah's data in multiple ways. They could use fractions, decimals, percents. They could use pictographs, line graphs, pie chart to actually display the data. So if we're looking at asking children to do these other more mathy things, the thing we can do first is just to ask them to sit with the context for a minute. The hardest part of word problems is understanding the context and making sense of the context in a mathematical way. And when children are noticing, they're starting to do that. They're starting to ask their own questions without even knowing they're asking questions. This also can lead to a project where children create their own surveys. Lots of us do that. Lots of elementary school teachers do that. Have children create their own surveys, collect their own data, report and display their own findings. A way to launch that is to have them use somebody else's data, make sense of that in the ways in which they would do their project, and then to have them go collect their own data. But I would suggest starting with noticing first. Final way to focus students on specific mathematical representations, or to use the instructional purpose, is to as a way to focus students on specific math representations. So we have lots of them. For example, here are some 5th grade and 1st grade examples. Look at all these different ways that math is represented. Some tables, we use linking cubes, we use 10 frames, we use just symbols, we show them clocks, we show them digital clocks, and we show them analog clocks, and we show them number lines. And oh my gosh, we just show children so many things. And we also put words in between things. So there are all these representations that we want children to make sense of, or we expect children to be able to make sense of, that if we just slow things down and have them notice those representations, notice the features of those representations, we're actually inviting them into math. And they're using their own thinking and their own languaging. And then we can attach the formal math language to it. But everybody comes with something. Everybody can notice something. And so opening up those doors to children, just to say, just be a mathematician for a minute and look at it and think, what do you notice? What are the math things you notice? And so this would be a great time to pause and really think about, if you have a partner or by yourself, just to pause and brainstorm some representations, some objects of study that are important to your students, maybe in the next few weeks. Like, what are some things that you realize that there are all these different representations, and I really want my students to focus on, they need to understand how all of these things are connected. So that's a way to select something for things I notice. That's where I start. I look at the unit I'm going to teach. I don't worry as much about the math vocabulary, to tell you the truth. I look more at the representations and all of the ways that things are represented. And then what I do is think about, what's the math in there? And what I encourage you to do as you're brainstorming, if you choose to do so, is to actually copy paste some from your digital textbook or with your camera, or just sketch some out. But to really think of examples that you could present to students. And honestly, if you look at word problems, just leave off the text That's all I did for the Liam and Noah problem. I just left off the question. I just left off all, sorry, leave off the question. Give the intro text, give the given. And once you've given the given, let kids notice some stuff about the given. Have them think about what they could solve using that information without even asking them to do so. They're doing so. So might want to pause and do that here. All right, I'm going to move on. So welcome back. A few rules of thumb as you are planning these out. So start from where students are. You really provide representations that have multiple entry points and multiple pathways. They should be contextual, right? So they should have some kind of context or meaning. They should have some meaning, right, in and of themselves. There should be something interesting to look at. And there should be lots of ways for students to notice, lots of things for students to notice. Make sure you provide thinking time. So the think part of think, pair, share, that's really important time to protect. Then provide time for peer-to-peer communication. And I know that's very challenging online. So if it means that children are not on it, if that's your situation, email me and say, my children are allowed to talk. Can we brainstorm some ways to make this happen? Just email me. We'll talk about it. My email's on this slide, in fact. Ask, don't tell. Just ask. Ask all your best teacher questions. So ask, how'd you get that? How'd you know that? That sounds like a conjecture. What did you notice that told you that? Just keep asking. And then establishing a routine. This is critical for all students, especially critical for English learners, to have routines in which to engage, because there are a lot of implicit things that happen in a classroom that the more we can routinize in a good way, the thinking routines, the ways that children are supposed to be, the safer space that is for kids. It doesn't mean that we have to be telling. That isn't what a structured environment is. A structured environment is an environment in which children understand what they're supposed to be doing, when, right? So right now, what should I be doing? Oh, we're engaging this routine. That's what I know what I need to be doing. And also provide language supports for your students. It's definitely like easier to do nowadays than it used to be. One last thing, I guess two last things. Why noticing? It's low stakes. There's something for everybody. It teaches students to take time with and make sense of what they're given. It cues them into knowing what mathematical objects and representations mean, that they actually have meaning. Some of our kids don't even know they're supposed to make sense. It's a really great formative assessment. It's a really great way to make sure everybody's ready for the day's work by focusing them. This is a great warm-up or do now routine. Kids come in, they know what they're supposed to do. I'm noticing. I can also use it for homework. It's homework that everybody can do, right? So if everybody is given something and they have to notice, then everybody gets to notice. When they come to class the next day, I might add a word bank. I'd say, go back and flesh out some more, put down some more noticings and maybe use some of these words if you didn't already use them. So still homework feeds right into my warm up and do now. It's all connected for children. There's a planning guide. It's on slide 9. This might be a great place for you to pause and engage in some of that. And again, if you have questions, email me on perry@rowan.edu. I love talking about this stuff. So please, we can even Zoom about it. So please contact me. And oops, finally, I guess we did notice some stuff. I guess finally end here. So resources for supporting English learners and multilingual students, 2 rich places to start. One is the New York State's statewide language regional bilingual education resource network. One thing, they have bilingual glossaries and cognates. They have one for elementary math and lots of languages, not just Spanish. And they also have guides and resources for educators of ELs. And they have lots of free webinars that you can go back and watch, and slides, presentations that you can go back and look through. And finally, Jeff Zweer's site. He works on authentic communication. His work around English learners is pretty darn amazing. So thank you for the time that you've spent here with me. I look forward to hearing from you. If, again, any questions, anything, let me know. Take care.